Hello. After very short break, we have yet another speaker on our Java path. Konstantin Slisenka from the Playtika will be talking about the architecture. And to not waste your time, Konstantin, the mic is yours. Have fun.
Thank you. Thank you. And thank you for coming to the online part of the conference. I hope tomorrow we'll meet each other in the venue. I will be in the venue tomorrow. So I'm going to talk about the architecture. The topic of my talk is about the architecture of the real product, which is already working for 10 years. So this is the practical case study. And my motivation to make this talk was to share the knowledge about the real project, how architecture actually went through the practice, because we learn on the practical examples. Yeah, everyone has some project in our careers, but if we want to be more experienced, we need to learn from each other to share the real cases. So my name is Konstantin Slisenka. I'm working at Playtika in a position of software architect. Playtika is the game development company, and I'm working here in the Warsaw office of Playtika. So I'm going to talk about the real product. This product is the mobile game, which is pretty popular game. It already having about 50 million downloads the Google Play market. And this mobile game started about 10 years ago as the startup, and it already 10 years, and the architecture evolved during this time. So I'm gonna not talk about like some specific architecture blueprint, but I'm gonna talk about different views on the architecture. For example, how architecture was in the beginning, what was changed, how the architecture was somewhere in the middle of this term, and actually where we are now, and what are plans to improve the architecture do we have now. So we will take this journey, 10 years journey of the architecture evolution of this game. And I want to emphasize that basically as an architect, I consider that the main value of the system architecture is ability to grow and accommodate more requirements. So in case the architecture is flexible, basically we can add more features, we can add more capabilities, the product can grow, and it's not limited by technical constraints. So basically our goal to make sure that there is no technical limitations of adding more stuff to the product, and while we're keeping this product stable. And here I want to advise a book, if you didn't get it yet. This is from my perspective, I found this book useful to actually talk about such concept of coupling, cohesion, and the principles of architecture design. And I was inspired by this book to write my talk as well. So we'll go to the beginning of this term and when this product was born, and many products was born as a startup. And this is why the software always starts small. So we need to still find if there is a market proof of the software. We have an idea, we're sketching, we develop in different minimum valuable products, and pushing these products to market, seeing how the users react, getting the feedback and improvement. So basically, in this moment, we are kind of finding the niche. And for this period of the product, there should not be any complicated architecture. We should build the architecture as quick as possible to basically unlock the quick prototyping, to make sure we can quickly prototype. And at this moment, the game architecture was actually composed of 3 components, 3 different deployable build units. We have the client application. This is the mobile app, actually the core game. Players download the game on their mobile devices. There was a server monolith application. We didn't go with microservices yet because there is no reason to maintain this complexity. Just one monolith, which implements multiple functions needed to support the client. And we have a third application, which we call back office, is the web application, which is used for the operators of the game, for some marketing people, for some game designers to make some configuration to view and upload the data into the game. And basically, those are the functions mapped to these three different components. So on the client, we had different features. For example, you can play the levels, you can play some side quests, you can see the leaderboards of the game, and this is pretty standard architecture of view, business logic, and there is some data behind it. It is on the client. The server mainly served the function of user authentication, collect and store in the analytical data. So there was also data warehouse here, and backup in the player data from the client. So there was no yet business logic on the server in this moment. And the back office application, also monolith, which allows kind of a view and modify this data. Those three components. So here was the technology stack in this moment, and basically client we still using Unity. It is the cross-platform framework for developing the mobile, and not only mobile, also the desktop games. It's a cross-platform framework. On the server at this moment, we used Google Cloud. So it was Google App Engine as the application runner, the Google Cloud Data Store as the database, a few other Google Cloud services, and the back office was developed as the application on JavaScript and Node.js, so the same person could do everything here. We used Elasticsearch as the operational data storage, log storage, and also Google Cloud services such as Google Cloud Dataflow and Google Bigtable. So that was the first, let's say, version. So as you can see, it's pretty simple. We could add more features and release new versions of the client app. We could also implement some endpoints on the server. We have the places to store the data. We have the place to store the operational data, analytical data, and we're able to authenticate the users. And that architecture was actually working for many years. So maybe about 5 years, it was enough. So we could prototype, we could add features, remove features, we could A/B test, and that was enough. So then we move into the next stage. Let's call it architecture 1.5. So basically the moment when we need to do the architecture change is the moment when we saw that the business value is proven. So the game become more popular. We're getting more and more daily active users, and this moment we also scaling the organizational behind the game. So now we have not one feature development team, but multiple, even more than 6 teams. And there are also many stakeholders, like business stakeholders of the game. It could be game designers, the economists, the monetization guys, operations, creative people, customer support, marketing. So basically, we have many teams which are working in parallel. We have many stakeholders, and as many stakeholders, they have a lot of change requests to the product. And basically, at this moment, we found it's pretty limited while we have this monolith application, because it becomes harder if there are like 6 or more development teams continuously contributing to the monolith. And the goal of this stage was to unlock the parallel development and releases, basically to be able to release and develop as many things as possible in parallel. And to make it possible, we need to, first of all, see where the system has a lot of coupling and decouple those things. And if we talk about the coupling, we can say that coupling is the measure of 2 components are coupled, 2 parts are coupled if they have shared knowledge or the shared life cycles. And basically, we need to find those things and decouple. For example, if we're talking about contract coupling, when there are 2 different components, but they follow some strict API contract, then we can say that there is a minimum actually shared knowledge. The minimum knowledge is shared with the API contract. And if we change the component B, it doesn't impact the component A. So we can develop those 2 components by 2 development teams in parallel. While if we have functional connections, a lot of data connections, a lot of code calling from component A to component B and vice versa. So basically changes in one component trigger cascading changes in the different component. So we should like split those components and use more like strictly defined API contracts. If we're talking about releasing the changes, So then we need to switch to the microservices whenever we need to release the changes separately. So here, if we're using microservices and if we're using not a monolithic web app, but some kind of the micro frontend container, when we can release a micro apps, multiple, like here, 3 development teams can work on these 3 services independently. And while we have a monolith, they are released only together. So there are big releases. Usually they're painful, they're more complicated, and the more risk of bugs. And if we're talking about more game design, marketing, and creative stuff, usually there are different teams responsible for development and for the content creation. So if we initially used just included the content, game content inside the release and then published, for example, the new quests, the new graphical, the new stories in the game. So here we need to extract those content, store it somewhere on the server, and be able to modify this content in the game without releasing actually the new mobile application. And the previous approach we used from the startup time, it's that we included this content and released. So basically we need to release new content every week or every 2 weeks, release the new version to keep the fresh content in the game. While in the new vision, the game should download it and we should be able to work it on the server. So that was the technical drivers for the architecture, basically to support as much parallel things as possible, to be able to develop the game, having the 6 or more development teams and have a separate team responsible for the content, separate for the application. And at the same time, we had some business drivers and new like major business, let's say, features or directions that we also need to address in this new architecture. So first of all is the content. So I briefly talked about it. So basically, assuming you play in the game and you always having some new quests or new tournaments, or there are new levels in the game, and so this is content. So we need to add new cool stuff to keep the game interested for the player. And as I mentioned previously, we had a static content release. So whenever we had any graphical files or any new quest, new stories, we included it into the build. So each time we need to make a QA of this build, and then we upload it to the App Store and the Google Play. While in the new architecture, the system should support downloading the content from the CDN, Content Delivery Network, or from the server. So we don't need to release the application anymore to just upload the new content. And we built a content management system for the game. So initially we had this client monolith. Let's consider it contains view and business logic, and we have this static content and static configuration inside the build. So we extract it. So we put this content and configuration on the servers. For example, we could use Content Delivery Network to distribute the graphical files. We could use some microservice to actually return you the configuration. For example, the configuration of the quest, on the tournament, of the goals. And the client now connects to the services and downloads it. And also we need to develop some web application to operate on it. And we introduced a micro frontend container because we don't want to contribute to this monolith web application anymore, because there are many different teams and each of them interested to making a change. So, and we introduced new applications. So the one for managing the content and one for managing the configuration. And second major business driver was the player segmentation. So basically we have like multiple types of players in the game. There are some beginner users who are more interested in kind of a first-time user experience content and game complexity, while there are experts. And for example, even they need to participate in different tournaments, groups, and different leaderboards, because it's not interesting to compete with like beginners if you're experts, and then the vice versa. And they may require different game designs. So we introduced the player segmentation system. So basically, we are collecting the game events from whatever how players are playing a game. We cache in those data, and based on this data, we can evaluate each player against some rules, and we can split the population. Let's say we can identify if those players behave like beginner or they behave like an expert. And we built a segmentation system. So let's say we had this configuration service, as I mentioned before, when the client can download the configuration, and there is the same data for the whole population. So let's say we have two different configurations. The one is the configuration for the game, which mostly a first-time user experience content, and the second one is the configuration for the very professional players. And those configurations should be downloaded depending on which population the player belongs to. So we built a segmentation service which evaluating those rules and making a decision whether the player belongs to the different population, and we need to fit those service with the data. So as I mentioned, we previously had the player data backups on the server, so we could send this to the segmentation service, extract the necessary data, and then evaluate the rules and provide the different content depending on the player population. And of course, we need to create an app in the micro frontend container because we need to manage it somehow. So as you see, we already have 3 apps in the micro frontend container. So then the very popular motivation for the player in the game is the social mechanics. Is actually about competing between the players. And obviously we need kind of tournaments and leaderboards so people could compete. And here we need to use the segmentation system because we want to split these players into the leagues and make sure that beginners are competing with beginners and experts competing with the experts. So it keeps interesting and keeps the passion for every player. And tournaments is something that we could only do online on server, so we cannot compete locally. And we introduced the new service. It's called tournament service when we put already the business logic of these tournaments on the server, and the client responsibility shrink to just viewing. So basically you play, you send the data to server computes your computes your leaderboard, and then returns your position, and you can see it. And we also need to support kind of an offline mode. So whenever you're playing offline, for example, your internet connection is not stable, and we cannot send the data in a synchronous way to the server. We need to collect your game events into the buffer, and whenever connection appears, we need to send it to make sure we're not losing your progress whenever you are offline. And of course, this tournament service connects to the segmentation service to split people across different leagues in the leaderboards. And we need to somehow manage it for the operation guys. So we introduced another micro frontend app to manage it. And another goal was the infrastructure optimization, because actually at this moment the game was acquired by Playtika, and we had this infrastructure in Google Cloud, which was defined initially. And the Playtika has their own cloud where we are deploying all the new stuff. And that was pretty complicated to support the system, which is multi-cloud, because we need to synchronize the data. So clients needs to connect to the both things. And we made the decision to optimize the infrastructure and migrate everything to the Playtika cloud. So this is kind of the technology stack comparison. So for example, in Google Cloud, we have the application engine, we have database as a cloud data store, we have message queue system as the Google Cloud PubSub, while in Playtika we're using Kafka, we're using Spring Cloud, and we're using a key value database, Aerospike. We're also using relational databases like MariaDB, and we use Kubernetes and Spring Cloud as environment for running the Java apps. But the more complexity was caused by the data migration, because we had a lot of data in the Google Cloud. And here you see that assuming we have a lot of population of players storing data in the Google Cloud. So first of all, we built the same system in the Playtika Cloud. We need to rewrite the code from Google Cloud App Engine to the Spring Boot and Spring Cloud. And then we created the migration service. So whenever there is any update in the database in the Google Cloud, this update event is synchronized, sent to the Playtika Cloud, and this data is stored in the database. And then we added the same mechanism like backwards. So whenever we're making any update in the Playtika Cloud, this data is synchronized to the Google Cloud database. So basically here we have kind of a dual write system. So then we created a URL dispatcher in the client. So depending on the segment, we can switch a user to one of these services. And then we turned off the Google Cloud system and completely moved to the Playtika Cloud once we migrated all the data. So basically, we first of all make the active data synchronization. So whenever players are playing, we synchronize their data. Then we're running the migration process for the players who didn't log into the game for a long time to migrate their data as well. We did the discrepancy analysis, so there were a set of tests which are comparing the data between two data centers, and we did a technical test with rollback. That means we migrated a small percentage of the users to the Playtika Cloud. We tested, then we tested how we migrate them back to Google Cloud. We see that there was no impact on the users, so we can move populations across data centers with no user impact. And then once we tested the rollback procedure as well, we introduced a gradual migration, migrating like population by population. So here there is some statistics about the data migration. About 50 terabyte of player data was migrated. And here we can see the architecture blueprint. So here we see some parts of the architecture 1.0. From the 1.5, we have these additions like content delivery network, the services, the segmentation service, the maker front-end container with the apps. And we have this, let's call it feature domain services. For now, it's tournaments, but we started to implement the new features and put business logic on the server and client acting as a view only. So that was the addition. So that was the architecture, let's say 1.5. So the purpose of this architecture was unlocking the parallel development and releases. So we can have many stakeholder requests, many different teams develop in parallel. And we used application and content release separation and microservices and micro frontends. And we are moving forward to the architecture 2.0. Basically, let's say we already can scale it at some point for many development teams, but there is still complexity of the system is still growing, which makes it harder to keep it stable and to develop new functionality. So this happening because of multiple reasons. One of the reasons is still there is a coupling, there are cascading changes, changing in the one place, need to track many places. And we developing similar solutions from scratch in many times. In many features, we just keep doing the same things, which could be optimized. And basically, we need, once we develop in solutions from scratch, we have a high cognitive load because we need to think about many things when we develop in the feature. So basically, the goal of the architecture 2.0 of this stage was reducing the development complexity to scale the organization. So first of all, we need to revisit the context boundaries, split it more strictly, introduce the contracts to make sure the teams can operate in their local environment and do not require knowledge about the entire system. We need to define some feature design standards and patterns and introduce generic solutions. Basically, whenever we build a new feature, we do not need to reinvent it again. We just used some approved blueprints and repeated. So if you're talking about the context boundaries, it's very important because the system design is about context boundaries. So we need to limit the knowledge of only one component and in the best case work within those boundaries and do not require knowledge about entire system so we can focus and reduce this cognitive load. And in architecture 2.0, we introduced a clean separation between client and the server. So we introduced a backend for frontend. So client no longer calls the platform services directly as we did before. And this backend for frontend allows to define the API, which is the most convenient for the client, and still make changes on the server without impacting the client. And second big difference, that we took the common pieces, repeatable work we do in every feature, and extract it as generic libraries or services or components. We call it feature development kit. So basically, whenever we start a new functionality, we need to repeat the same things. And why do we develop them from scratch? We better implement it as reusable stuff. So there was like two main directions. For the feature design standards, we found that there are two patterns of the features in the game. The features that require the internet connection, and the features that can work on the client and should work very, very fast. There is a very active user interaction, and we should download everything to the client and keep it running. So we should use at least internet connection as possible for these features. For example, online first features, when we require internet connection, server is source of truth. So business logic is on the server, client is only working as the view layer. While here you see that we already used this architecture for the tournaments. So there was the view only, and here we have the buffer for some game events. So whenever something happens in the game, we can save it in the buffer and then send it to the server. And business logic is on the server. So we decided to take this layer of client-server communication, we call it partially online toolkit, and extract as generic component. So we can reuse it and reuse this blueprint. While in the offline first features, basically the client is source of truth and it contains all the business logic. So here we defined the mandatory backend for frontend, while we have business logic separated, is concentrated on the client and some platform services behind this backend for frontend. So we operating with these two blueprints, and basically to make it powerful, we need to make as much reusable components as possible. So one of the directions was this rewarding flow. So in the game, we making some quest, we're earning some resources, and we can spend some game resources to, for example, to upgrade our characters or to build some stuff, or to help us with progressing in the levels. So we introduced kind of a rewarding toolkit. Whenever we use something some components to display the reward in the game, to configure the rewards, to have this transaction, for example, remove the gold, but make some building or upgrade the character. And whenever we need to do analytics, we introduce the common components for this. So anytime we build a feature, we just reuse the common components. We connect into the feature to the resource flow. There was also improvement in the player state synchronization. So basically, I already talked about this partially online toolkit. So this is the framework which allows the data exchange between client and the server. It's tolerant to the poor network connection as well. So we extracted it as a framework and keep using the features and do not develop this from scratch. And there were improvements related to the game operations flow. So for example, we configure some new tournament or new quest. The operations people, they do some pre-launch verification. They're launching this tournament. And whenever the tournament is launched, we need to stick it. For example, do not allow any changes in this tournament until the user completes it. And if we look in the previous architecture pattern, so we see we had some features, and we implemented the same things in the same feature. For example, in each feature, we implemented the code to allowing to pre-launch this feature to test it and to stick the data. While the configuration service, it has only the configuration, storing the configuration of this feature. So in the new architecture, we moved as much as possible to the configuration system and let the features be smaller. So basically, while we're developing the features, then we should only think about business logic, but more common stuff we should put on the platform layer. So basically, this is how architecture 2.0 is composed. Here we have still some elements from the architecture 1.0. It's still here. It's still 10 years old architecture. We still have it. We already talked about the 1.5. So we have this business logic on the server and the feature domain services when the client acts only as a view. We have these platform services like configuration, segmentation, and we introduced this micro front-end container when we put in more apps. We can manage the game. And at the architecture 2.0, it added the backend for frontend, mostly for this platform services, and this feature development kit, which is composed on some libraries and reusable components. So basically, this is still our direction. So we keep improving this feature development kit. Whenever we do any feature, we see something can be reused, we contribute into this. And right now we're still following this paradigm, which allows us to introduce even more features in the game with and keep scaling it. So to sum up the journey of this architecture for the 10 years, so we started with the very simple architecture. It was the startup time, so the architecture should support the quick prototyping. There was 3 components: client, server, and back office, and it was living for maybe 5 years in these boundaries. There were monoliths. While we reached the bar of like organizational size of multiple development teams, many stakeholders, we got the problem of a lot of changes to this monolith, a lot of releases, and we need to split it. So we started splitting it into microservices. We used micro frontends, micro apps, and we split it also the content and application release process. So the content team can work completely separately to the development team. And in the 2.0, we were dealing with complexity. So we need to make sure we reduce development complexity as much as possible. So we introduced the more strict context boundaries, so teams can work more in isolation. And we introduced the feature design standards. So whenever we build a feature, we kind of follow existing best practices we learned and extracting as much possible common functionalities into the common libraries or services or components. And we call them feature development toolkit. So there's things that we can reuse and focus mostly on bringing new business value, but not on solving the same like infrastructure problems again and again. So here we are right now, and this is the direction we keep following. So basically, that was my story for today. I hope you enjoyed it, and yep, I'm ready. If you have any questions, I'm glad to answer. And if you want to catch me, I will be in the conference venue tomorrow, so we can talk about it. So thank you very much.
Wonderful. Thank you very much, Konstantin. I have one question from the public. In future, the related development teams, who is responsibility for developing generic libraries? If they are features, if they are development teams that are focused on features, who is responsible for the plumbing and for all the infrastructure and libraries and everything?
Okay, so it could be done in multiple ways. Whenever I'm participating in the architecture design with the development team, usually I am defining which things team needs to contribute to the generic components, and this is included in the feature scope. So basically, whenever we build in a feature, we're trying to also improve the generic components. This is one way. Also, we have, we call it a green backlog or like technical debt backlog. So basically, feature teams can allow to spend some of their development time for non-business task for solving the technical debt. It can also include those contributions, but this is up to the team decision. So they can make a decision, and we have one of the teams specifically dedicated for non-business stuff. We call it the technical team. So responsibility of this team also includes contributing to generic components, but not only.
Okay, thank you very much. We have yet one question, however, we do not have time to answer it. So thank you very much. Michał, if you want to, Konstantin, if somebody wants to ask additional question, you can reach you out on LinkedIn or somewhere, yeah?
Yes.
That's
yes,
okay.
Please.
Okay, thank you very much. It was wonderful talk. It was great to hear your story. I love the startup vibes, and see you next time. Now we are switching to the yet another presentation. Have fun.
Yeah.
Have a good day.
Thank you.
It was a pleasure.